Okay, hello everybody. Hello. Hello. See, I can be you guys as well. Hello. Don't make me yell like Jashank does. Hello everybody. Hello, hello. Shh. Shh. Is the microphone okay at the moment? Is it good? Is it bad? It's good. So I noticed in the lecture recording for the Wednesday lecture last week, the microphone was like rubbing against my shirt, being really crunkly. So if it starts being crunkly, please let me know so I can fix it. But yes, hello everybody. Welcome back to COMP1511. It's week 10. Who's feeling excited about it being week 10? Who's feeling really stressed and tired and uni's hard and life's hard? Yeah, quite a few of you. But that's okay. We have some fun programming today. So today we will be looking more at linked lists. So after the lecture today, we looked at linked lists last week. We're going to look at linked lists this week. We're probably going to look at them like they're a tool that we will use in future weeks. Like how we use if statements all the time now, right? And it's not special to use an if statement. Linked lists are another one of the tools that you will add to your arsenal. But after today's lecture, you should hopefully understand linked lists better. You should be able to write code to create a list, traverse a list, and solve simple problems using lists. So, number one, don't panic. It's week 10, right? Who is feeling stressed out? Who is feeling like uni is getting really hard? Those of you who didn't raise your hands, is it because you're somehow zen and happy? If you've learned how to do that, please teach us. Please teach us. But the point I'm trying to make, uni gets stressful, right? Week 10, things just pile up and pile up and pile up. You have assignments, and then you have the exam coming soon, and everything's hard and scary. But that's okay. You will get through it. Shh. If I've managed to survive a very large number of years as a student, then you can too. But basically, don't panic. And on that note, assignment 2. How are you going with assignment 2? Who's got a program that will run at all? Code that will do anything at all for the assignment. That's not as many hands as I was hoping to see. How many of you have code that will make a legal move? So it might not win, but it'll make a legal move. That's pretty good. How many of you have got some code that will actually win against the AIs sometimes, win against Lulu and Morgan? Okay. How many of you are like coming first on the leaderboard? One person raises their hands. Clearly it must be you. So, I mean, you probably couldn't see the number of hands that I could see, but most people have started the assignment, and a bit over half of you have an AI that can play legal moves. Shh. And that's the point that you should try and be at by now. You can play legal moves. Who hasn't started yet? Being honest, okay. I would just like to say I am deeply disappointed in each and every one of you individually. Please start the assignment. Start it during the lecture now. Like, ignore me and start the assignment. You have my permission. But watch the recording later on. Anyway, shh. That's about it for assignment 2. If you've got any questions, ask on the forum. Assignment 1, your tutors will be giving you marks, hopefully by now, if not soon. The feedback they give you about your style is very important. Please pay attention to this, and please use it to write better code in this assignment. Shh. I know it's really boring when I say things like write good code, but seriously, if you had to mark code for this assignment, you would understand the pain of having to mark bad code. So make your tutors happy. But seriously, ask your tutors for feedback on your style. Show them your assignment 2, get feedback on that, and so on, all good. Week 9, weekly test is out, do that. Don't forget about help sessions. I made a whole page for the help sessions. So we have 1, 2, 3, 4, 5 more help sessions this week. So those of you who haven't got the assignment working to an extent that you're happy with, go to the help sessions. There's one Wednesday, tomorrow night, there's one Thursday night. Those are in J17201, so the same building as the level 3 labs, but the floor below. Then on Friday we have 3 help labs, 10 to 12, 2 to 4, 4 to 6. And I'll try and come along to these ones as well. I turned up last week, so you can get free help from me as well. Cool, but shh. Hopefully that's all good. Go to help sessions. Shh. And now let's move on to some content. So hopefully you remember from last week, we have this concept of a linked list, a list made of nodes, like a series of kind of, is that echoey? Turn it down a bit. Is that, can you still hear me? Is it echoey? No? Cool. So we looked last week at linked lists, which conceptually are a series of nodes, like a series of circles, blobs of memory, each of which knows how to get to the next one after it. And so this is the code for it here. I'm going to walk through the code in the slides and then actually do the coding in the coding. So I thought I'd look at the code first, and then after that we can write the code. So remember, our node struct has some data. So for example, a number, and then it has the address of the node that comes after it, so the way to find the node after it. Those of you, would you like 30 seconds to finish talking to each other and then we can go on with the lecture? Okay, time up. Now pay attention. And it also knows how to get to the next node. And so then we can make a node, struct node hello. So hopefully you're feeling sort of okay with structs after the lab last week. Maybe you're actually thoroughly confused. But hopefully you're feeling sort of okay about structs. When we say struct node hello, struct node is a type, like how int is a type. And so we have a variable called hello of type struct node. And since that has the data and the next field, I've drawn it down here in this beautiful diagram. The data field has 10 in it, and the next field has null. Null being the memory address we describe when there is no memory address. So like the value that means this doesn't have a memory address in it. And so we don't have a star, we just have struct node, because we actually are explicitly making this piece of memory in the memory of the function. And then we access it like hello.data equals 10. We can then make a node using malloc. We can dynamically allocate memory for it. So I'll ignore this for now. The usage would be like struct node star hello equals make node 10, for example. Struct node star hello means that hello is a pointer to a node. It's like an arrow that points to a node, not a node itself. And that stores, it looks exactly the same. We've still got the same, the value in the next. And then we actually make this with our make node function. And I'll walk through this code in a minute, but it's here to look at first if you want to. We malloc some memory for our node. We set its value and its next pointer, and then we return it. And by the way, these slides, you should be able to access them on WebCMS. Has anyone been able to view them there? Did I get the permissions right? Cool. A couple of you can view them. So if you go to the course website, you can follow along with these slides. I think I actually got it right this time. And then, of course, freeing a node. So in accordance with Newton's third law of memory allocation, for every malloc, there is an equal and opposite free. So basically, when you malloc memory, you must free it afterwards. Not immediately afterwards. This code here does nothing. It makes a node, and then it frees the node, and it does nothing with the node. You shouldn't free it until you're finished using it, but you should free it. The syntax for that is just free. Cool, and then this is something that I spent a while rambling on about and drawing pictures for last week, and you were like, Andrew, this makes sense. But you might be going, Andrew, this makes no sense. So this is a really important concept to get. When we have a reference to a node, an arrow, struct node star, that's like the arrow, versus an actual node. I have a picture here. When we say struct node star, we mean make a pointer to a node. This is just an arrow. This doesn't have a node itself. It's just a way of saying there's the node. When we do something like malloc, we're saying actually make the memory for a node. So I drew this beautiful diagram last night. I hope that it's beautiful. And you can even read the colors. Awesome. So this is, if you want to take a photo of something, take a photo of this and try and remember this. When we have a struct node star, that's just an arrow. That's a pointer to a node. That's the way to find a node. That's not a node itself. That's, here's how we get to a node. The node itself is the memory that we get through malloc, for example. Yes. Does this make sense? Are people confused by this at the moment? Cool, either you're not confused or you're asleep. I'll take that. Cool, and so let's actually do some coding of this stuff. Cool, so I guess I'll open my code from last time if I know how to do that. Week 10, week 9, Wednesday, list. Cool. I added lots and lots of comments to the code from last week. Actually, let me also show you. So on the course website, whenever we have diagrams and stuff, I try to edit the video to add diagrams afterwards. I can't edit the Echo 360 videos, like I can't change what's there. So instead, I put them on YouTube, and you can see the Wednesday video is up, the Tuesday video is not, I'm sorry. But you can see, I won't play if you don't want to hear my voice. You get to hear one of me is more than enough. You can see all the diagrams are drawn on top, and the code and stuff. So watch those videos. It'll be great. I'm hearing laughter. Was there like a silly suggested video or something? Yeah. This is why you don't. Yeah, computers. But I will copy this bit here. This will be enough. Cool, and so this is my kind of base file for linked lists, my sort of raw file. I'll add a main function. Cool, and now we are at return 0, like a beautiful blank slate. Like from here we can do anything we want with lists. There are, I guess, a couple of things to do. I'll write them as comments here. So actually making a list conceptually, we need to be able to make a node. And let me check what I've written down so that I say all the right things. Cool, so we need to be able to make a node. We need to be able to like make a list, which is a series of nodes joined together. And we do that by sort of adding a node onto an existing list. I'll write that as a comment and explain more later. What else did I write down? Cool, we should be able to remove nodes from list. And of course, when we make a node, delete a node. So would you like me to draw diagrams alongside what I'm doing? Would anybody not like me to draw diagrams alongside what I'm doing? Okay, does anybody have an opinion but didn't raise their hand and now wants to have an opinion? Should I draw diagrams? Okay, that is, yeah, enough people raised their hands. I'm hoping for next week that I've got a system set up that will mean I can do everything on one screen. So I won't have to edit the videos and it'll all be there straight away. So I very much hope I can get this working for next week. And it will be awesome for all of us. Laptop, projector 2. Cool. Ugh. Okay, so the first thing we need to be able to do when we make a list is make a node, right? Or to make a node, we have to be able to make a node. So the thing I just said a whole bunch about, like the arrows versus the circles, how do I go about making a node? What are sort of the 2 steps, or the 2 colors that I had? One of them was like making the actual memory of the node, and the other one was like making the arrow to point to the memory. So when I say struct node star, I mean what we call a pointer. Like this is how to get to the memory address. This is the memory address of the memory. And I'll call it hello, because I can't think of a better name. And so then how do I allocate memory? If I want to make memory using some function that has alloc in the name. Malloc, cool. And so what does malloc do? Yes, it gives us memory in the heap, but it gives us memory. Cool, it stands for like memory alloc or something. So then what do I put inside my malloc? Yes, the size, the number of bytes that I want to allocate, right? How many bytes big is my struct? Is it like 5? Is it 10? Is it 100? Do I need to know? Size of, yes, I can do size of. So this size of operator, it's sort of like a function, it's sort of not, we just pretend it's a function. Size of struct node will give me the number of bytes big that my struct is. And so if I say malloc size of struct node, I'm saying allocate me the amount of memory that is the exact right size for this struct. Cool, so now I have, I promised pictures. Yes?
Why do some people put the type before malloc, like in brackets? Like there's some money,
Ah. Cool, that's a very good question. So the question was, and I'll do it with an int because it's easier to write than having to write all these words. Hi, variable names are so hard. Int. So if for some reason I wanted to allocate myself 1 int worth of memory, because I can, int star high equals malloc size of int. This will allocate 1 int worth of space in the heap, in the place that's not the function memory, and then give me the pointer to it. So this is the code that you will see in this course, the way we write it. If you look online, you might see it written like this. Not like that, like this. And so what this means, you don't have to do this, by the way, but what this means is you're giving me a thing of some type, but actually I'm saying it's this type. So you're saying actually the type of this thing is an int star, is an int pointer. This is often a bad idea to use typecasts. This is called a typecast because things have types for a reason, and you don't want to be saying this thing of some type actually is this other type because things will go wrong. The reason for this in this case is that on, I think, older versions of C, where's one of the tutors to tell me if I'm right or wrong? No, the tutors have all left, it's just me. Oh no, students and no tutors, you guys are going to mob me. So I believe that it is in older versions of C, you had to have this here. I didn't know what to do, because malloc will give you a void star, like a pointer of no known type, and then you would have to say, by the way, it's an int pointer, and then say int star blah equals this. But in the version of C that we're using, it's smart enough to know that when we say int star thing equals malloc, we do want to get an int star out of it. Do it this way. Did that answer your question? Did that confuse everybody else? Okay. Are there any questions about the confusing thing that I just said? I guess the short version of it is you can write it like this. If you see it like this online, you don't need to do it that way. You can just write it like this. Cool. Was there a question over there? A stretch. Cool. I'm going to try and save all of the versions that I typed, so it'll be good. Okay. Delete this from list.c. Excellent. So struct node star hello equals malloc size of struct node. Give me 1 struct node worth of memory, and then put the address of it in this thing called hello. All right, I was drawing a picture before I was so rudely interrupted with a question. That was like sarcasm, by the way. It's fine to interrupt with questions. So this is the memory I get from malloc. Malloc gives me this. And then when I say struct node star hello, I'm saying, has it gone quiet? Is that better? When I'm saying struct node star hello, I'm saying hello is an arrow that can point somewhere. So it'll start out just being an arrow not pointing anywhere, pointing in limbo. And then we say equals malloc size of struct node. Malloc gives us the address of where that memory is. And so what we're doing is we're saying hello points to this blob of memory. So hello is the name of the arrow. The memory itself is given by malloc. Is this all good so far? Cool. And by the way, we draw nodes as circles just with the number in them, even though the struct itself would look like this. There's like our number 10. There's our next, could be null. Sorry, hang on a second. Oh, I'm not recording this. Let me record that. Okay, diagrams. Diagrams are there. Everything is good. So when we make a struct, technically the struct looks like this. It has 2 fields. One of them is an int. It's got 10 in it maybe. One of them is a pointer. a memory address of another node, which is null on this one here. But when I'm drawing the diagrams, I just draw a circle. And so this, for example, I would draw like this, saying that I have a node with a value 10, and the next field points to null. Shh. So the reason for drawing it with the circles is it's way easier to draw circles than to try and draw boxes like this. But that is what I mean when I draw a circle. So how do I put the value 10 into here? If my node is called hello, how do I access the fields of a struct? Have the name for a start. What do I need next? Someone said arrow, someone said something that I didn't hear. I'm going to pretend you said arrow. Yes, we need an arrow. Good answer. So hello arrow data, for example. This is saying go to the thing that hello points to. So hello is a pointer, this one here. Go to the thing that it points to, which is this actual node here, and get its data field, which is this number 10, for example. Or if we wanted to set it to be equal to 10, we can say hello arrow data equals 10. How would I set the next field of this to point to null? What's the first word that I type? Hello. Yes, hi. Nice to see you. Cool. Hello. Arrow. Next. Someone who's not that guy. Equals null. Cool. And now both of you can't answer more questions for 5 minutes. You've reached the limit. So does this make sense? Are any of you sitting here thoroughly confused, going, what is hello, what is the arrow, what is data, what is next? Do you have a question? Yeah?
Why do you sometimes use like one times size?
Yep, so I'm going to cut you off and guess your question. I'm sorry. So are you saying, why do we sometimes use malloc one time size of? Yep. So the question is, why do I sometimes have one? The answer is because it's really clear that I'm trying to allocate one of them. If you're making an array, for example, you might say, malloc 10 times size of int, right? And that makes you an array of 10 ints. I sometimes write 1 to make it really clear that I'm just making one node, so that it's obvious that I haven't forgotten to put a number in there. But in the case of making nodes, you can pretty much just do this because you only really make one node at a time. Does that make sense? 1 times a number is the same as the number itself. The rules of math apply in this size of thing as well. So these are equivalent syntax. Cool, good question. Are there any other questions or any other major confusions? Yes?
So is the pointer pointing to a specific memory point and then it's one node? Or is it just making some specific memory?
I didn't quite understand the question. I understood and then you confused me with the second part of the question. Can you say that again?
Is hello the address for an actual memory part for that's called node?
You've said that that's called node, and I think that's the part. I'm going to answer the first part of your question, pretend you didn't ask the second part, and then if that answers your question, that's good, right? So is hello the memory address of the memory of the node? Yes, it is. So when we do malloc, malloc allocates memory and gives us back the memory address. And to prove it, I'll print it out. Does anybody remember the printf syntax to print out a memory address? %p? Someone said x, someone said p. Both of them are valid. I'll use p. P intentionally wants a memory address. X could do a number as well. Hello. And so remember, hello is a variable that contains an address, so I can just print out hello as it is, and that will give me the address. Here. It compiled. Cool, so the address stored in hello is this number here. Cool, 0xF5500710. Shall I do a whole bunch of mallocs just for fun? The address from this malloc. Okay, so what is wrong with what I'm about to do? There's several things I've just done wrong. What's one of the things I've done wrong? No freeze is the second thing I've done wrong. The first thing I've done wrong is I've copied and pasted code. If you're copying and pasting code, then probably you're doing something wrong. Either you're doing a lecture or you're making mistakes. So hopefully not the same thing. Yeah, you could put it in a function and reuse the code. Since it's only one line of code, it's not much difference. What? Oh, I forgot the semicolon. How many of you have written a program and not had a compile error? Like the first time you wrote it, it worked. Well, it compiled. A couple of you, yeah. It's compiling code is hard. Excellent, it compiled. So we can see here, I've got, Windows are so hard. Okay, so I've done malloc size of struct node, and I've printed out its memory address here, this line here. And then the next line I've done another malloc, and another malloc, and another malloc, and I'm printing out each of their memory addresses. So you can see each of these has a different memory address. Each time malloc is giving me a different blob of memory, and it's saying, okay, here is your memory, it's at this address here. And putting that, in this case, putting that address into hello. And in these cases, it's just printing the address out and then the address is gone. And so this is bad because we can't free the nodes now, we can't free the memory. Like, with malloc the memory, we haven't stored the address somewhere, so we can't free it again afterwards. But yes, malloc will give us back a memory address, and then we can put that into some sort of pointer, like a struct node star, and then store that address, so that we know how to get to it. Many malloc. Cool. Does that make sense so far? Cool. And so we've made a node here, hello, but that's kind of boring because we can't see that we've made it. We're not printing it out or anything. So let's print it out. The value in hello is... So if I want to print out the data field of hello, what do I need to type? Hello, arrow, data, yes. Hopefully everybody knew the answer to that question. If I want to print out the data field, I give it hello arrow data. Conveniently, that line was also written above right there. Sorry, the value in hello arrow data, the value in hello arrow next. And I'm going to print out hello next as a %p so that we can see it's a memory address. That's the wrong file. Why do I always do this? Okay, that's roughly the right place in the file open list. Cool, so we make our node, we set the values, and then we print out the values, and then hopefully that makes sense. Compiled, yay. Cool, so we can see the address stored in hello, because hello itself is a pointer, it's an arrow, it's not a node, it's an address of a node. So the address stored in hello is this one here. The value stored in hello arrow data is 10, and the value stored in hello arrow next is nil. It's pointing to null, it's not pointing anywhere. Hopefully that is all good. I would like to show you a common mistake that people make. How about, let's do a thing. I'm going to freeze the image, and then I'm going to make the mistake. And then if you weren't paying attention, you won't know what the mistake was. And then we can see what's gone wrong. Cool. So have a look at this code. Don't say what the problem is, but see if you can spot the problem while I drink some water. Who thinks they've seen a problem? Who can't see a problem and is like, what, this looks the same? And people who didn't raise your hands, are you asleep, ignoring me? So let's run it and see. The best way to find your mistakes is to run your code and see, and then it won't work, and you won't know why. And then you'll be confused, and you'll spend hours and hours trying to work out what's going on. That's what programming is like, unfortunately. Cool. I'll do that in full screen so you can experience it. Cool, and so it's printed out. The address stored in hello is this. And then it said runtime error, illegal array pointer or other operation. Execution stop here in main. Hello error data equals 10. Something has gone wrong. So looking at this code here, and I'll delete this line so you can sort of see it all at once. It's printed out, the address stored in hello is blah, which is this line here. It's got to this line here, hello error data is 10. And it's gone, no, I can't do this, runtime error, something illegal has happened. So how many of you have seen this illegal array pointer or other operation? How many of you have had this error at some point? Those of you who haven't raised your hands, are you like pretending that, are you asleep? Or has anyone never had this error happen? A couple of people, okay, you should try harder. So what this is saying, you have done something that you are not allowed to do. In this case, often it means you're trying to write over memory that you're not allowed to. Like if you're looping through an array and you print out, say your array is 3 big, and you print out array 0, 1, 2, and 3, that's 4 things, not 3. So you've gone past the end of the array. In this case, we've done a similar thing, but rather than the array, we've gone over the end of the memory that we've been given. If you look carefully at this, I've got malloc size of struct node star. So I've allocated enough memory for the address of a struct node, which is like half of the node itself, right? So when I try and add things to the data field, it's going, well, the struct node star is only the size to fit this one here, so it can't also fit this one here. And this is a common mistake that you will probably find yourself making at some point. If you have the struct node star, I'll draw a diagram again. So this is a struct node. It has the value 10 and the address null, for example. When we have a struct node star, we just have an address. So when we allocate the amount of memory for a struct node star, you can see it's like half as much memory as we need to have. Or even if it's not half as much, it's only enough for one of the 2 parts. Okay, does that make sense? Do people see why that is a bad thing to do, and you're not going to do that ever again in your lives? You're never going to make this mistake? Yeah? So was the question, if I do size of this plus size of this, would that work? Yes, so this would work here. I could say size of struct node star plus size of int, because this is the contents of the struct node. But then you'd have to add on explicitly all of the size of all the things you wanted to have. So instead we'd just say size of struct node, because that knows how big all of them are. Cool. I'll close that mistake. And I'll open list. List.c. Cool. Okay, so hopefully this is all good so far. What I would like to do next is make a function to make me a new node. And how about I go to my slides so I even do the same thing as I did in the slides. Okay. So in order to make, if I want to have a function that will make a new node, I just make a function, I guess. I'm gonna call it new node. So functions have something here, a name, something here, something in here, and something here. So which of these steps do you want me to start with? What should the function return if it's going to make me a new node? Someone said void. It should return us something. If we make a new node, what do we need to have? If I say the new node is this memory here, this blob with a 10 in it, I need to know how to get to that memory, right, so that I can actually use that memory. So struct node star new node means this will return a struct node star, return the address of a node. Cool. I'll move all of this over here. Instead of hello, I'll call it new. I'll ignore that for now. What should I put in the data field of my node? Should I let the user give us a value? Yep, that sounds good. Value and data, I'll call it value, I'll call it data, cool. So new arrow data equals data. And this means the thing calling this function gives us a number, and we put that number into the data field. We're going to set the next field to be null, just so that it's like a fresh node, a clean node. It doesn't point anywhere. It explicitly does not point anywhere. What would happen if we didn't set it to null? What would be in there? Be some random thing. Should we like try it and see? No. I'll try and do it in the second half. Andrew Taylor's added a really cool feature to DCC that I will try and trigger sneakily so that you can see it happening, but that might need more work than just that, so I'll do that in the second half. Cool, so struct node start new node. A function called new node returns a node pointer, returns the address of a node, takes in a data, allocates me some memory for a node, sets its data to be this data field here, sets its next to be null, and what have I forgotten at the end? Yes, return. New. If I don't return, then I'm not giving the address back to anybody, so it's not useful. Cool. So now this should make us a new node. Who asked the question? So what was the question? Can I change it to?
Change the data to user input or something, because that's kind of confusing.
As in change the number? Change the name?
Change the name, yeah.
So the question was, can you change it to user input or something because it's confusing? It's not necessarily going to be user input, it's the person making the node. So that might be the user in a loop, or it might be you typing it in your thing. I'll keep it called data if that's okay. Cool, and then let's make a print node function to print out a node. If I want to print out a node, what do I need to take in? If I want to print something out, what do I need to know? I need to know the thing to print out, right? So where it is, cool. Struct node star node. Excellent. And what should my function return? If I'm printing something out, yeah, void, it shouldn't return a value. I take in a node and then I don't give you a node back, I just print out the value of the node. Like I'm not giving you anything back. Cool, find, replace. Hello, node. Cool, hopefully that was only the ones we wanted to remove. So we have a print node function that will print out the things in our node. So before we were printing them out in the main function, this is just that code in another function. We have a new node function to make a new node. Again, the code from the main function before is now in a function. So then to use this, if I want to call new node with 10, what do I need to put on the left-hand side here? What type, like what data type do I need to store this if it's an address? Yes, struct node star node. So this says struct node star is make me an arrow. Make me a thing that will hold a memory address. So it's called node, it'll hold some memory address, but like conceptually it's an arrow. It's this thing here that will point to a node. And then when I say new node, that's a function that will give me back an address of a node. So it'll make me a node over here, put the value 10 into it, and then give me back its address. So let's say the address is 1, 2, 3, 4, 5, because that's an easy number to write. And so conceptually, node is this arrow that points to this 10 over here. Cool, hopefully that makes sense. And then to print it, print node, node. I'm calling the print node function, I'm giving it node, which is a variable of type struct node star. It's a variable that is a memory address of a node. And then it'll come in here and print out the value and the next field. Cool, so hopefully this will do exactly the same as what it did before, except without breaking. I haven't declared my prototypes. I almost remembered. I was thinking to myself, oh, I need to not forget them. So I got a whole bunch of errors here, implicit declaration of function, blah, 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 blah. I forgot my function prototypes. It always happens, every single time. So where should I put my function prototypes? Does it matter? Like they've got to be above main, but Can I put them here? You keep saying after the struct. Why after the struct? Yep, exactly. So I can't put my prototypes before the struct because I'm using the struct as a thing in the prototype. So at this point in the code, C is like, what is a struct node? I don't know what a struct node is. But if I put them down here, then at this point in the code, it knows, a struct node is this thing I've just seen here. Cool. Did I do enough function prototypes? Yes. Cool, and so it prints out the same as before, makes a node over here, calls the new node function. I'll move that sideways. The new node function allocates me memory for a node, puts the value in it, then I print the node. Hopefully this is all good so far. I've made a node. What do I have to do? The opposite action of making a node. Say the word louder, people. If I've for every malloc, you must have an equal and opposite. Free, yes, very good. So let's make a function. I'm going to write the prototype first this time. Free node, cool. So what should my free node function return? Probably nothing, because it's just freeing a node. It's not like giving us a node. And it should take in a node, because we're giving it the address to free. Cool. Let's put that one down here. So then how do I free a node? What's the syntax? It's very complicated. There are sort of 2 words involved. Free and node, perfect. So to free a node, the opposite of malloc is free. I just call it the free function, literally the word free, and give it the memory address to free, which in this case is being stored in the variable called node. And so now, in theory, and I'll move this one in between, this will make me a node, print it out, and then free the node. Compiled. Cool, so nothing looks different from before. The value is this, the value in the next is this. What happens if I don't free it and I run dcc -- leak check, I believe it is? Hyphen check, or? You sure? Please hold while I read the instructions. So if you type generally any program in Linux like -- help, it'll give you the instructions on how to use it. This is how to use DCC. That's quite a lot of instructions. Computers are hard, I'll just scroll up. Something with a leak in it. I'll just let you tell me what it was. What was it? Hyphen check. Yes. Very good. So dcc-o list.c -- leak - check will check for memory leaks, hopefully. Cool, and so it's printed out like before. The value is this, the value is the node data is the node next is this, and then error free not called for memory allocated with malloc and function new node and lists. That's such a nice error message. That tells you exactly what the problem is. You guys are so lucky. I'm going to run that again and you can just admire this. Free not called for memory allocated with malloc and function new node and list.c at line 36. So line 36, we did a malloc and we didn't free the memory from this malloc. Can I just show you the pain that we had to go through when I was your age? Do I have to do just G for Valgrange? There we go. So this is what it would look like back when I was a first year. We'd get this thing here, rerun with this, and it's probably going to have the same useful information now that I've said this isn't it. That didn't actually tell me what I wanted.
It tells you have 2
2 allocs and 1 free. It's very helpful information. There we go. Definitely lost this malloc here and this thing here, this thing here, this thing here. See how confusing this is? You guys are so lucky. Anyway, back to where we were before I got amazed by. Cool, free not called, and so we need to call free for our memory. Here is the free we're going to do, and now when we run it, we compile it, and run it again. Everything is happy. Are there any questions? Do you have a complicated question?
What happens if
So the question was, what happens if you don't free it? So the answer, the nice answer would be it stays there forever and it's like using up memory in your computer and it's just going to get worse and worse, so you should always free your mallocs. The real answer is it'll be freed when the program ends. But you shouldn't rely on this, because if you're writing a program that's more complicated than like 5 lines of code that should run for more than like 5 seconds, then, or more than 0 seconds, then it will use up memory and things will be bad. Okay, shall we take a break? Let's have a 10-minute break. If you have any questions, I'm happy to answer some. I have to change the projector back to the computer because the computer sounds come from that one. I can select that for now. Cool, I hope that you have had a good break. I hope that you haven't been stuck in one place like me for the whole break, not moving. So, is that a good volume? I feel like I'm quieter than I was before. Is this a good volume, a bad volume? Can you hear me? Do I sound too echoey? Is that a thumbs up for good or a... Cool, thumbs up for good. So, unrelated to the lecture, but related to this room, the air conditioning turns off after 2 hours. The person in here before us turns it on, so the aircon turns off in the middle of our lecture. So if it's getting stuffy in the second half, be like, Andrew, turn the aircon back on, because I've got to turn it on like halfway through the lecture. So if you are getting stuffy, that is a thing that can be done. Awesome. Okay, so back to the linked lists. Oh, that's not the right button. Sorry, I've just realized that. So I put a new hard drive in my laptop and I haven't set up UniWide yet. And because I'm running a custom window manager, I don't know how to set the Wi-Fi network. So it's computing people make problems for themselves. Sure, it wouldn't be this hard on Windows. Anyway, but back to the linked lists. So we have made functions to create a node and delete a node. A couple of questions during the break that I might just answer again to everybody. When I say something like struct node star new node int data, that data refers to this variable here called data. When I say new arrow data, that's the data field of the struct that new is pointing to. So like new arrow data means go to this struct that I will put over here. That one. Cool. So if we have a struct, and it's called new. So struct node star new. New is a pointer to this memory. It contains the memory address of the memory. And so new is a variable that contains an address. So in memory itself, new is this memory address, which might be like, because that's totally a legit memory address. So some number, that's the memory address inside new, which means that's the memory address of that. Let's use simpler numbers. So if this was in memory at 0x100, new would contain the memory address 0x100. So when we say new arrow data, we mean go to this, let me grab another color. Go to this variable new, which has this memory address in it, go to that memory address, and look at the data field inside that struct, which is this one here. So new arrow data means this field here, and data here means this variable that we've been passed in. Cool. Hopefully that is all good. So now we have worked out how to make a single node and print out a single node and free a single node, and that's all good, but I said they were called linked lists, right? Not nodes, single nodes. So let's look at making a list with multiple nodes. Okay, that never happened. So let's draw a picture first. If I want to make a list that's sort of like, here is a node, it's got 10 in it, and then make it point to some other node, so its next field has the address of the next node, which has 20 in it, points to a node with 30 in it, and so on. How would I go about doing this? I've made myself a node. It contains the value 10, so this one here is node. How do I go about setting this part here, setting the next field of our node? You forgot the first step that I want. So I go node arrow next to get to the next pointer within the node. So looking at this one here from before. So node arrow next means change stuff inside this next field here. And if I want this to contain the memory address of the next node in the list, how do I get the memory address of the next node in the list? I mean, for a start, the next node in the list doesn't exist, so I need to make the next node in the list. When I call this new node function to make a new node, what does it give me back? What's the return value? The memory address of the new node. So if I want to make this one here point to the memory address of the next new node along, how do I do that? Yes, and can someone other than you answer questions from now on? So person whose name I do not know did have the answer right. So to make this one here point to the next node, I make the next, like I give it the memory address of the next node, right? And I can do this in one step by making a new node with this new node function, which will give me a new node, set the data field for it, and return the memory address of this node. So this one here is saying set the next field of our existing node to be the memory address of this new node that is created. And so in terms of diagrams, that looks like this. We have our node, it currently points to null, which we draw as an X. We then say make its next field point to the return value from new node, which is this memory address of this new node that it makes with 20 inside. Cool, does that make sense? Cool, and then how do I access the next field of this node? If node arrow next gets me to this one here, how do I access its next field? I put another arrow next, right? And this syntax can be a bit confusing, so let's try node arrow next is how I get to this 20 node. So that's like saying the 20 node's next field, or node arrow next equals new node 30. So this will make me a new node, put 30 in it, and then make 20's next field point to 30. Cool. So now I have a list that has 10 pointing to 20, pointing to 30, or a node with 10. The next node is a node with 20, the next node is a node with 30. Shall we? Like, this is kind of boring because I can just make a whole bunch of nodes in here in the program. I can't like dynamically make them. So let's make a function that will let us make nodes and add them, like make a node that the user gives us the value for and then add it on. That was quite confusingly spoken. But let's start out by having a way to print out the list of nodes, because it would make more sense if we can print out the list when we've made it. So looking back at these slides, the word traversal means like to traverse a list, traverse an array means go through every element. So taking a step back for a minute to like a couple of weeks ago when we did arrays, this is an example of a function to go through every array element and do something to it. So it would say, int I equals 0, while I is less than the array size, do something, set the value, print out the value, do whatever, and then I++ to go to the next node. So importantly, like the loop structure is the while loop, having I being a counter that goes from 0 through to some number. In comparison with a linked list, instead of having our I++ to get to the next one, we have current, which is our pointer to the current node that we're looking at. And then we move along to the next thing in the list by making our current pointer point to the next one along. Let me draw a picture for this code. Hang on, I had a list there already. So what this is saying, I have this list and I have a pointer to it called called list. And so struct node style list is a pointer to this list itself, which is the first node in the list. I make a new pointer called current, and I point that to the list. And then I say while some condition we'll think about in a minute. Current data equals value, so we could change the value in it, for example. And then this important thing, current equals current next, means that this current pointer here, this is not the 10 node, this is this arrow that points to the 10 node, should contain the memory address of current arrow next, so the field after current. So if this is current arrow next is this memory address here. And so current equals current arrow next means make this current pointer point to this next node, or in terms of like the under the scenes, current now contains the memory address of this node here. Then we go around again the next time, current equals current next again, means the memory address inside current will be equal to the memory address of its next field, which is the address of 30. Cool, and if we did it another time, current equals current next, the next field of 30 is pointing to null, like it contains the value null. So current is now pointing to null. What would happen if we went current equals current arrow next, if we tried to go like null arrow next? Can we get the next field of something that does not exist? If it doesn't exist, can we get the next field from it? Please say no. No, we can't, because it doesn't exist. Very good. So we'd call that dereferencing a null pointer. You can't go, if this is null arrow next, because it'll go, what are you doing? Illegal operation. So once current is pointing to null, we want to stop our loop. So it's rather than having like when I is equal to 10 if the list is 10 big, we're saying when current is now equal to null, we want to stop going through our loop. Hopefully this makes sense. Are there any questions about this code, which will not be answered by writing up the code again? I'll chuck this here. So let's change this to be a print list function instead. So we're going to go through the list. We start out by making ourselves a pointer current. So this is an arrow that will point to the first node in the list for a start. While this pointer is not pointing to null, we won't set the value, we'll print it out. Current arrow data. So this should print out the number and then an arrow, so it looks like a list. And then current equals current next means we make current point to the next thing along. And so then current will point to the 10, it'll point to the 20, it'll point to the 30, it'll point to the thing after the 30, which is the null, and then it'll stop, because current is no longer not pointing to null. Does that make sense? Cool. I'll take your lack of words as a lack of confusion, optimistically. So to print out my list, this node here, the pointer called node, is the first node in the list. So I want to give it the first node in the list, and then it will keep walking through the list, finding the next thing, the next thing, and the next thing, hopefully. What did I forget? I forgot a function prototype. You should tell me when I forgot my function prototype so that I don't have to compile it and feel bad. Said you couldn't answer questions. You can tell me if I've forgotten prototypes. Okay, compiled. Cool. Our code must be perfect. I'm not freeing my nodes. Oh, I'll just remove leak check. Because if you're getting like a warning or an error in your code, you can just tell it not to give you the warning, and then your code's fine. Note that I'm joking. If it breaks on CSE, then it's broken code. So this sort of works. It's showing me that 10 points to 20 points to 30 points to the value in node. I didn't quite get my printing right. Let's make it look like that. So what I want this diagram, I want this to look like 20 arrow, 30 arrow, X for null. So I will need to print out the X at the end. X, new line. TCC, list. Cool, so it's printed at 10 points to 20 points to 30 points to null. And so we've done this by, for each of the nodes, printing out the number in the node and then this arrow showing the next one. And then at the very end, printing out X to show null and then the new line. So now we can print a list. This means we can make a list and actually see it by printing it out. So let's do that. So let's make a function, just write some code. We'll make a function, because functions are great, to scan in numbers from the user and then make that be in the list. So they'll give you a number, you make a new node, you put that number in, they give you another number, you make a new node, put that number in, and so on. We'll call it make list. I wanted to give me back a list, so struct node star make list. Give me back a list in the sense of give me back the memory address of where the list starts. It's not going to need any input from the function parameters because it's just going to make a new list. Cool, okay. So enter a value. No, that's not how you do that. Int number, scanf %d into number. Hopefully this is looking very week one, familiar, happy. Printf enter a value in number, scan the number. But rather than just printing out a number, we want to put this into a node. So how would I make a node with this number in it? There's 2 words for a start. This function, new node, number. Oh. And so this will make me a new node with the value from this number we've scanned in. Cool. It's giving me the memory address of the node, so what do I need to store it in if it's giving me a memory address? Someone said something star, yep. Struct node star, a name, node equals new node. Cool, and so what this will do, this will get me to give you a value, take in the number, put the number in, make a new node, and let's print the list. This is going to be a list of size 1 prototype, thank you. A list of size 1, so it's not going to be very interesting, but that's okay. We can go with it. I said that I'd return the list that I made, so I should return the list. Yes. Oh, I need to call my function. If you don't call your function, then nothing will happen. Let's just comment all that out. Make list. Cool, enter a value. 5. Cool, we've made a list that contains 5, and then 5 points to nothing. So we just have a single node, I'll draw a picture of here, a single node with the value 5 in it. Very interesting. Points to null. So let's make this more interesting then. Let's make more than one node. So if I wanted to make another node, I reckon we need a loop. I reckon if we want to do something multiple times, we need a loop. Do you agree? No one agrees? So why did I not put the loop in the main function? Because this function should make a whole list. It should scan in numbers repeatedly. That's just what I've defined the function as doing. Oh, while something, do some stuff. All of this here. Okay, so how do I scan things in until I can no longer scan things in? Like what can I do as a while loop condition to scanf until there are no more numbers? While scanf %d into number equals 1. So while this has scanned in one value successfully, which means I will need to put that one up there, and that one over there, and then also inside the end. So enter a value, we're going to scanf into number. If it succeeds, we'll go into this loop. We want to make a node with that number in it, print out the list, and then we'll go around the loop again and make more and more things, and life will be great. Yes, that's a good point. So should I then put the printf at the end of the loop again? Yes, because then we're going to scan another value and it'll make sense to the person. I want it to not give me the error without giving away the thing that I'm trying to do. I'll make it there. So I've just moved my variable declaration outside of the loop so that I can return it at the end like this. Actually, it's a good point. I don't know if we've talked about scope. I think we've talked about scope. So when I have inside my while loop squiggle brackets struct node star node, node only exists inside these squiggle brackets. And then at this point here, the variable node no longer exists. Like its lifetime, its scope is limited to inside these brackets here. So I need to put it outside to be able to use it, like to be able to return whatever's in there. Cool, didn't forget a function prototype. I'm into 10, to 5, into 2. Something is happening. My lists are all not lists, they're just one number. Oh, I was supposed to type Control D. Shall I do leak check as well? And then 10, 20, 30, 40, 50, 1. Okay, a whole bunch of numbers. Free node call for memory allocated with malloc and function new node, and let's see at line 72. It didn't tell me how many there were. That's not very nice. Oh well. So the problem we have here is we're not freeing the nodes, right? We're making a node, but then we're not linking that node up to anything else. And so we're just having a node and then we're making a new list with a new node and losing track of this one here. Shall I draw a picture for this? I have in here scanning in a number and then saying node equals new node number. So if the person typed in 5, I make a node here with 5 in it. And then I'm saying that my pointer called node, I'll put this down the bottom, points to this node 5 here that I've made. I then print out the list, which is just the 5. I then go around again, scan another number. Shh. I say node equals new node with whatever number they typed in. So if they type in the number 10, shh. I make a node with the number 10, and then I make a node point to this one here. But then, what's the problem here? How do I get to the node 5? At this point here, what can I do to get to the node 5? Yes, correct. The answer is nothing. So there is nothing I can do. I've lost track of 5. I don't have the memory address of that node with 5 in it anymore, so it's just lost forever. So what I want to do instead then is somehow make this one point here, and then this one point here, right? So I want to make 5 have the memory address of the one after it, which is the 10. So how could I do that? I need some way to keep track of the one that I'm up to. Maybe I could just go node arrow next. No. I'm going to rename these so that they make a bit more sense. So I'm making one of these be called list, and this is going to be the pointer for the very first node in the list. So maybe let's have a scanf here to enter the first value and just assume that this works. Cool. And so we've scanned in our first number here. And so we're saying list is equal to new node number. So list is the memory address of this first new node that we've made. Like this. And so then we want to enter a new value. We want to scan in, we want to make a new node somehow, put some number in it. Then we want to make this previous node point to the new node we've made. So if I have list here and I want to set its next field to be pointing to the new node, how can I do that? If you remember what we did up here, right? I can just say make its next field directly be equal to the new node function, or the result from the new node function. So what this is going to do is this is going to say, okay, list is this first node here, this 5 over here. And then while we get a number, list arrow next is the new node. So list points to this 5 node here, set its next field here, set this arrow here in a different color, to have the address of this new node we've made, this 10 that we've made here. Cool, I'll get rid of that one. I'll then print out my list, starting from list. Enter another value. So this code is a little bit closer to write. This code still doesn't do what we want, but it is closer. So this will start out by getting a number and then putting that in as the start of the list, scanning in another number, and then making the new number we scan in be the one that's second in the list. So 5 will point to the 10, for example. But this has a problem. Maybe you can spot it now. Maybe you will spot it shortly. List.c. Okay, enter a value. I'll put 10 at the start. Put 5. So I've made 10 be my first node here. I've then made 5. I've gone inside my loop. I've scanned in the number 5, and I've made the one after 10 be the node 5. Right? So if I type in 6 here, what's going to happen? Who has absolutely no idea what's going to happen? I won't make you say anything. It's fine. You can raise your hand. Okay, who is too scared to raise their hand? It's a bit recursive. Okay, so who does feel like they know what's going to happen next? Who's looking at this and going, yeah, okay, I think I know what's going to happen next? Okay, people who didn't raise your hands, are you asleep? Are you like, do you not want to raise your hands? What's going on? I guess if you're asleep, you wouldn't hear me. You look awake. You're looking at me, but I guess being able to look awake when you're asleep is a very useful skill for lectures. So what's happened here? It's now, I've told it to make me 6, and it's gone 10, and then 1 after 10 is 6, and then that points to null. So what's happened here? I've made a new node. I've put the number 6 into it. And then I've made list arrow next equals this node here. Shh. Right? So this next field of this node here, 5, is now pointing to this one here. But I've lost 10, so this is bad, right? So what I really want to do here is make 5 point to 10, but then 10 point to 6. So we've solved this problem a little bit at the start, but we haven't actually solved it overall. And so in order to do this, I need a way to keep track, like to move along as I insert new ones, right? So when I've inserted the 5, I want to know I've just done the 5. Then when I've inserted the 10, I now want to go, this is the one I've just inserted. And so then when I insert another one, I know it's the next one of this one that I've just inserted. That was probably very confusing, but that's okay. And I'm going to make a pointer called current, C-U-R-R, which will... I'm going to make a pointer called current, and this is going to keep track of the one that we inserted most recently, like the most recent node that we made. So current is going to start out being the same address as this. And then I'm going to want to go here, current arrow next equals new node. What did you say? Okay. So these are lines that you'll be very used to writing soon. You will type this out 1,000,000 times in your life. Current equals current arrow next, like practice now. You will probably type this out like at least 1,000 times over the rest of semester. Maybe, maybe not. So what I'm doing here, this is like from before when I was printing it out. I'm saying, I'll move this node over here. Much better. So I'm saying current starts out, when I say current equals list, I mean current has the same memory address inside it as list does, so it points to the same place. And then current arrow next equals new node number, so that's me going make a new node, put the 10 into it for an example, and then make it be stored in the field, the next field of the thing that current points to. I then say current equals current arrow next, which means current now has the memory address of this one's next field, so this now points to this one here. Right? And so then when I make another one, if I set it in current arrow next, that's going to be the next field of this node here, which will be the place we want to make the new node, and so on. Cool, and so then the next time the loop goes around, current is now pointing to the new one we put in, and then the new one again, and so on. Hopefully. Cool, it compiles, good start. So let's add 10 for start, let's add 5. So the list goes 10, then 5, then nothing, let's add 3. 10, then 5, then 3, then nothing. Let's add 8, 10, then 5, then 3, then 8, then nothing. Cool, this is doing exactly what I said it should do. Yay. And then it stops at that point when I hit Control D. So does this make sense? What I'm doing is I'm making my list, I'm putting a node on it, I'm then making my current, like my green arrow there, point to the node that I've just put in. So then when I put another node in, I'm putting it in as current arrow next equals. So inside this, the node called current, or the node that's being pointed to by current, its next field I'm making be equal to the memory address of the node that we've just made. So that's the equivalent of saying, here's a node, and you can get, like its memory address, you can get to it by going here. And then saying current equals current arrow next, I'm saying set current, which holds a memory address, to be equal to the memory address of this one over here. And so current will now point to the 20. And so then when we put it into current arrow next again, that'll be the one after the 20 and so on. Can I go through the code just one more time? I can go through it many more times over the upcoming weeks. I just want to try and think of a way to not have this out here. Okay, so it's messy having this code repeated twice. Like we want to reduce repeating code. So if I just put this inside here, then let's get rid of that altogether. So if rather than making the first one separately outside, I just made the first one inside here, something bad will happen. Do you know what bad thing will happen? I'll give you a clue. I have a struct node start current, but I haven't made it point anywhere. I haven't given it a value to contain. So then I'm saying current arrow next equals new node number. And so I'm trying to say, go to this thing that you don't really have a thing there that you point to. So let's see how it breaks. DCC is telling me that I'm doing it wrong. Here we go. So we've got this error. I'll do that again. I'll look at the code again. So I've gone struct node star current here. So I've made myself an arrow, but I haven't given it a memory address. It happens to contain whatever memory address happens to be there. I've then said, in this bit here, current arrow next equals new node number. So I've tried to go to this memory address that's whatever random stuff, and I've tried to access the next field inside that. And the computer is going, you cannot do that. Technically, member access with a misaligned address for type, or in other news, you can't do that. Like, you're pointing to something that you shouldn't be pointing to. So, how do I get around this? It was also telling me somewhere uninitialized. We'll live with that for now. So I could say something like current equals null, right? And so I've given it a value, but it still points nowhere. So I will run it again and it'll crash again. 1 minus, it's close enough. So now it's saying member access of the null pointer of type struct node. So this points to nothing, but we can't go like set the next field of nothing because that is not allowed. But we want it to be that once we've done the first one, it'll go around and set current next field, right? So I need to have what I'd call like a special case to handle the case of the first node. And so what I mean by this is I want to go, if like we're scanning the first node, then, you know, scan the first node properly. Otherwise, if we're not scanning the first node, I want to scan into the next field of the one that we're up to. Shh. Right? So the question was, why didn't I just initialize it outside? Because I want to have all of the scanning in this one loop. I don't want to have this code here.
Why do you want to have it all looped up together?
Why do I want to have it all together in the loop? Maybe, good question. I guess because that's the way that we do linked list things. This is the way that we expect you to write linked list. It's a good question. It feels messy to me to have this same code copied and pasted here and then also in here. You can disagree. So if we're scanning in the first node, we want to do this stuff here. We want to say that list is equal to this new node, and then current is equal to list. The reason for this list thing, by the way, if I'm going to return the list at the end, I need to be able to return and say, hey, this is how to get to the list. So I need to know how to get to the first thing in the list. So I need to keep track of that separately to everything else. So if I'm scanning in the first node, then I want to go, so current equals the new node with this number, and then have my list have the same memory address as this. So my list pointer will point to the first thing on the list. And then I never change list later on, so list will always be pointing to the first thing that was there. Cool. So if it's the first node we're scanning in, we want to say current is equal to the new node. We can't say current arrow next because current doesn't exist. We can't go like null arrow next. So if it's the first node, we do this. Otherwise, for all of the other nodes, we do this like we had before. I'm not going to ask, does that make sense? Because it probably doesn't. I'll ask one more thing first. How do I know if I'm scanning in the first node? So looking at my code up here, I set current to null. If I am at this point here, and I haven't changed current yet, then current is still going to be null, right? So I can check if current is equal to null. If my current pointer is pointing nowhere, then make it point to the new node, make the first node. Put a comment in there. Make the first node in the list. And then the else is add node to existing list. Cool. So does this make sense? What are the questions that you have? Who is confused and may or may not have a question? Okay, confused people, do you have any questions? Why don't I just move this separate code outside the loop? Because I don't want to have this scanf and stuff happening outside the loop and also inside the loop, if that makes sense. I don't want to have a separate printf entry value scanf and number in and then also do that inside my loop here. Cool. I don't really have a good answer for that because I want to do it this way. I'm sorry. I'll have a good answer for tomorrow. Is that okay? The question was, why do I want to do it like that?
Because isn't it less efficient? You're testing an if statement every time you go through the loop. So you just have to declare an outside limit into the loop instead of testing.
Let's talk about that much more. So before we finish up, right? Shh. So add a value, 20, 30, 40, oh man. What did I mess up? This is genuinely unexpected.
You didn't for that else statement. You haven't put
So the problem I had here, I had this here, and so I'll explain that tomorrow if you would like. DCC. Cool, and so now it does what I want. Inside my loop here, I scan in the values, and I make the list with the values in it. So shh. If I'm making the first node, I have a separate case for that word called, and then the rest of the time, we just add the node to the existing list. Shh. You have 4 more minutes of trying to sit there and be quiet, and then we'll go. If you can do 4 minutes, okay? You can like watch a clock if you have to. Cool, so does this make sense? Are there any questions about this? Okay. So would you like me to walk through the code one more time? Yes. Cool, I'm happy with that. So, shh. Just looking at the code again from top to bottom so you have like a picture of what it's all doing. The main function calls the makeList function. So main just says make me a list. Inside this makeList function, we make a number just to store the number that we scan in. Shh. Please be quiet for 3 minutes, okay? 3 minutes, you can do it. I hope. I mean, maybe you can't, but you're like 18 or more, I think, 17 or more. Anyway, so we make a number to store the number that we scan in. We make a pointer called list that will point to the start of the list so that we can give back the start of the list when we return. We make a pointer called current to keep track of the one that we've scanned in most recently, so the most recent node that we've added to the list. We then print out, enter a value, and then we scan in some number. If we've scanned in a number successfully, if we got a number, if it's the first node in the list, so if current is still null, if we haven't changed current to not be null, then we're saying make current be the first node and make list be current. So when we do the very first node, we make our very first node, because it's the first node, current is currently pointing to null. And so we're going to go, okay, make current point to this new node here instead, and also make our list pointer list point to it as well. So another pointer called list, so we can keep track of the start of it. And so then we've done that. We've done the if, so we don't do the else. We print out the list, and then we say enter another value, and we scan another value again. When we print out the list, actually, I'll do another one of these. I'll add another node first, then we'll look at that. So then we scan in another number. So let's say they type in 20. If current is null, current is not null. Current is pointing to the list, the node that we've just added. So we're going to go down here. We're going to go current arrow next equals new node number. So we're going to go current arrow next, set the next pointer inside current to be a new node. Shh. Contains the value 20. You have literally 1 more minute of being quiet. And then we make current point to this next one here. We say current equals current next. So current now has the memory address of the node that we've just made. And then we go scan another number, make another node, scan another number, make another node. When we call print list, what print list does, it has a current pointer that starts at the start of the list. While this is not null, it prints out the data in that one, and then it makes current point to the next one. So if I drew this with green, I'm saying current starts out by pointing to the start of the list. While current is not null, print out the thing there, so print out 10. And then current equals current next means current now has the memory address of the next field, so it points to the 20. We go through again. Well, current is not null. It points to 20, so it's not null. Print out the 20, point it to the one after